For the Fluent Flow project of the wind tunnel, the first thing we're going to do is we imported the geometry from SOLIDWORKS as a .IGS file. Make sure your analysis type is set to 2D. So you have that, make sure it's saved. And then the next thing we're going to do is go into the mesh, which will take a little bit to load. Okay, this is pre-meshed. So what we did is we set the mesh to an all triangles method, and in that we made sure that the element size is 1 to the power of 10 to the negative 2 in meters. See, these are triangle mesh. We originally looked at doing inflations on the edge of the wind tunnel, but we decided just to keep it simple. Keep mesh as a structured triangular or unstructured triangular mesh. So you would generate that and make sure you update that. Since this is already pre-done, we won't need to update this, and we can go straight into the setup. One thing that's important to note, though, in the mesh, you have to make sure you name the pressure inlet, or the velocity inlet, and the pressure outlet. Now we'll go into the setup. Set it to double precision. Right here, what my mouse is showing would be the velocity inlet, and here would be the pressure outlet. So we're going to go into modes and make sure your energy equation is turned on. So see, it is. And we're going to go into this setting. You want to turn on K epsilon in the two equations, and then go and hit Enhance Wall Treatment. Select OK from that. Next thing we're going to do is we're going to want to set our velocity inlet. So go to Boundary Conditions, go into Inlet, Velocity Inlet. And right now we're going to change your magnitude to the correct velocity, which in this case is 2.626 meters per second. You can get this by taking the frequency or the hertz given and multiplying it by the equation that was also given in the project files, and then taking the height ratio of the contraction chamber, and you divide the your number from the equation by the contraction ratio to get the correct velocity inlet. Apply this. The next thing we're going to do is we're going to initialize the simulation. Then we're going to go to Run Calculations. And I personally set it to 300 iterations. I'll probably take less. That's what I like to do just in case. Calculations are complete. So this is pre-made. So if we go into graphics and we go into contours, we're going to do a contour of the velocity and the x velocity. And we're just going to have just collect surface body to make sure the mesh isn't shown. And you're going to compute it and then save and display. What you can see here is the contour of the x velocity following the center line. Go to the next contour. So this one, it's going to be the velocity magnitude in the x direction. We're going to compute it, save and display. This is what it looks like. We can go on to contour 3. We also have one for dynamic pressure and total pressure. Then we have the plots that you can make, XY plot specifically. The XY plots, half of them will be following the center line, line 5, which you could plot one of these lines by going to the line right and then selecting the points or using the mouse. In this case, this is following the horizontal center line. Save and plot it. And this is what it looks like at 30 Hertz. So as you can see in this one, we're using line 6 for the velocity magnitude. Make sure when you're dealing with the y-axis, you're going to set your plot direction to 1 in the y, and then set your x to 0. And obviously, if this was in the x direction, we'll set our x to 1 and our y to 0. And we can ignore z in this case because we're only in 2D. So this line 6 will be in the test chamber, and it's a vertical line. So this is what we get for our vertical line with velocity magnitude in this test chamber. And what I mean by a vertical line, it'll be centered right here in the test chamber. And that's how you do your wind tunnel meshing in Workbench and Fluent. Thank you very much.